Hello students, as we have discussed two examples previously and now moving towards another good example. Let's say you have been given such type of geometry and we have to find it out. It's a magnetic field for such type of figure. Let's say these are the two things you have been given to previously. Let's say this much part contains, let's say your radius is called as R2 and this one much part is containing that radius R1. My current is started to be flown from these points and completing its journey. So let's say I'm just mentioning my current, there is no value mentioned over it. These are the points from which my current is passing. So this is it's a journey of a current from point A to B, B to C, then C to D, then D to E, and again come back to the part A. And this one is my radius R1. So you can see such type of geometry from the figure. You can say this is my angle. So you can mention that my theta 1, that is called as let's say I'm just naming it as a theta 1. That is called as a theta, and this one is my theta 2 for the remaining part, and that is called as a 2 pi minus theta. So I just found it out such type of two values. Now I am in a search of my magnetic field. So for my understanding, a simple task I am performing, I am just putting and saying that my current is passing from B of AB, and then B of BC, then B of CD, then B of D, E and A path. You can see from the figure A, it is passing from A to B, then B to C, then C to D, then D, E and A path. It is completing its journey. So as we have learned that as per our current is passing from first of all A to B part, it is in the direction of our angle, and that is why angle would be 0. So very first part is that it will become 0. Then it is passing from B to C. Yes, it is showing that, so it would be there B of BC. Again C to D part where my current is in the direction, so my angle will be 0, so my magnetic field will be 0. Then D, E and A part where you can say that it is there, so DEA part will be available to us. Now what we are doing is that putting their values. You can see that from the figure I can say that I have only two parts available to me. So I can just say that net magnetic field will be of a combination of BC and B of DEA. Now as per our notation, you are aware about our formula. I have mentioned it previously for you, which is called as a B is equals to mu 0 I divided by 4 pi r and multiply by angle. We will apply over here. First of all, we have a BC part which is holding that angle, that is called as a theta, or you can say that is called as a pi by 2. So we can just say that our value B is equals to mu 0, current's value is I, then 4 pi, and its radius is called as R2. My theta, I am first of all putting theta, then I have mu 0, current's value is 4 pi r, and that its radius part is called as r1, and I am just putting that 2 pi minus theta. So now bringing it out common part, I have a mu 0 I divided by 4 pi theta divided by r2 and plus 2 pi minus theta divided by r1. So this is the value. Yes, you can just say that theta equals to pi by 2 and simplify this thing, but yes, this is the only simple method we have. So with the help of only simple formula you have, b is equals to mu 0 I theta upon 4 pi r, you can simply solve such type of a critical examples. So I'm just giving you a task, and with the help of such formula, let's see that how you are solving such type of examples. Let's say your task is like I am just giving you a square which is having that length 2a, and my current is flowing in a circular fashion. So you have to find it out magnetic field at its center. So what would be that magnetic field at its center. Yes, I'm just giving you hint that you can also follow our usual conventional formula. B is equals to mu 0 I divided by 4 pi r into theta, or you can see that two parallel wires, and you are aware that whenever two parallel wires are there, what we will use is that two parallel wire theory, which has given us a formula mu 0 I divided by 4 pi, and that midpoint distance from that point to the current carrying conductor, perpendicular distance, it is called as a 4 pi a, and sine phi 1 and sine phi 2, this is called as, let's say, phi 1, this is called as a phi 2. If you are aware about the theory which is already there in our channel, theta 1 and theta 2 are also there, so you can use also another formula. It is up to you which angle you are following. Mu 0 I upon 4 pi a cos phi 1 cos phi 2. Be careful whenever you are using this formula of a sine or cos, whichever angle, if you are using such type of angles which are called as a perpendicular distance angle, and theta 2 and theta 1, which has been only direction of our current, so you can use any two formulas or the previous formula. So only by learning primitive equations you can solve so many complicated examples as we have solved in the previous clips. So in the next clip we will move to the another important aspect, and there are some of the comparisons between the electric field and magnetic fields. Hope you may have joined such type of examples. If you have any query, you can comment in the comment box, and if it is possible for the majority of people, we will just give you and download another video for your critical type of examples. Thank you.